In the previous tutorial, /posts/go tutorial project structure / you learned how to organize a Go project. Now it is time for Go's most powerful feature, goroutines. Let's break it down. Goroutines versus OS threads. Goroutines are not operating system threads. They are much lighter. The Go runtime multiplexes goroutines onto a small number of OS threads. This is called an M scheduling model. M goroutines run on NOS threads. Sync.wait group. Waiting for goroutines. The correct way to wait for goroutines is sync.wait group. It counts active goroutines and blocks until all finish. Output order may vary, but all workers finished is always last. 3 methods to remember. WG add 1. Call before starting a goroutine. W done. Call when the goroutine finishes. Use defer. W wait. Blocks until the counter reaches 0. Important. Always pass sync.wait group as a pointer. If you pass by value, the goroutine gets a copy and the original never decrements. Race conditions. A race condition happens when multiple goroutines access the same variable without synchronization. One goroutine reads while another writes. You might expect the counter to be 1000, but it will often be less. Multiple goroutines read the same value, increment it, and write back, overriding each other's work. The race detector. Go has a built-in race detector. Run your program with the race flag. Output. The race detector tells you exactly which line has the race condition. Always test concurrent code with race during development. Sync. Mutex. Protecting shared data. A mutex, mutual exclusion, ensures only one goroutine accesses a resource at a time. Output. Now the counter is always 1000. The mutex ensures only one goroutine modifies counter at a time. Sync.rw mutex. Multiple readers. Single writer. If you have many readers and few writers, sync.rw mutex is more efficient. How many goroutines can you run? Let us test it. Output. 100,000 goroutines use about 200 megabytes of memory, 2 kilobytes each. You can easily run millions on a modern machine. Goroutines with anonymous functions. You will often use anonymous functions, closures, with goroutines. Important. Always pass loop variables as function arguments. If you capture them directly, all goroutines might see the same value because the loop variable changes before the goroutines run. In Go 1.22+, the loop variable is scoped per iteration, so this issue is less common. A complete example here is a practical example. A concurrent web page fetcher. All URLs are fetched at the same time. The total time is roughly the time of the slowest request, not the sum of all requests. This is the power of concurrency.